Okay, so today's lecture is all about, we'll be focusing on project quality management and also procurement management. So to begin with, for this, for project management, if you can remember well, we've come across the PM BOK knowledge areas. So there are quite a number of them. So for your project management course, you're supposed to actually be well familiar with all those knowledge areas. As we know, there are 10. Some of them you might have covered them already, but a few of them you might not have touched them yet. So there are things like project scope management. We have done that already. Cost management. We have touched it. HR. I'm not so sure if you. No, I don't think we've really touched it. Project risk management. That one we've touched it. Stakeholders. And today we'll deal with project procurement management. Communication. I think that one we've touched it on the previous lecture. Even in your notes, it's well detailed there. And then now today again, we'll deal with project quality management, then time management and project integration management. What you will notice is that after you are done with this course, you should be well familiar with most of the business concepts. You should be able to understand how the entire mine, for example, how the entire refinery or smelter, how it comes together. Because in most of the courses that you have done, you're mainly just focusing on the technical skills, the hard skills on metallurgy specifically. But these ones, it will make you well rounded. Even if you are to become a manager or even a general manager, you should have an appreciation of what is happening at HR, at the risk, at procurement. You need to know communications, project quality, all those things. So you get all those skills in this course. Are you with me so far?
In this course.
Yes, sir.
Okay. So project quality, basically project quality basically is focusing on on the quality of the project, on the project deliverable or the final product that you are producing from that project. So it's not just quality of the materials that you are using, but of the final product itself. So it implies that the product or the deliverable that you are producing, it must be fit for the intended purpose as you have agreed with the client. So it depends now on what the client want to use that product for. So you need to make sure that that product that you're producing, that client should be able to use it or should be able to apply it for whatever that it's intended to be used for. So for a high quality project, it's basically the one that meets all the performance requirements, and it satisfies the needs and the expectations of all the key stakeholders, especially the customer or the client. So you need to make sure that everything that the client wants that product to have, it will end up having it. Otherwise, that customer will not be, of course, your customer will not be happy. And if your customer is not happy, then it means you have a big problem again. So ideally, the project you aim to go beyond the specifications that you have agreed on. You try to basically impress your customer. They say you should delight your customer, so that in case you have another project in future, they can actually call you off to come take over that project. Remember, this course is not just opening your mind in terms of metallurgy alone. It might also be, some of you might be interested in becoming entrepreneurs. Not all of you will be just focusing on production alone. No, some of you might become project engineers. Some of you might have your own company where you are working on projects in industry, but you have your own business. So you need to fulfill the customer expectations and make them happy. And then next time they can give you another project, or maybe it's a tender, they can give you another tender. So this is the course that helps you with all that. So with this course, you become well-rounded. So it improves your business acumen. So if you can recall, at the beginning of the course, you have touched on on the triple constraints and also the quadruple constraints. So the project must be on spec in terms of the schedule. It must be cheap, or it must not be that expensive, and the scope also. But the other dimension that we did not look at yet is the quality of the project. So your deliverable. So there's a level of quality that must be that the deliverable must have. So you must achieve that deliverable. Otherwise, they will say your project is of low quality if it doesn't delight the customers. Okay, now in terms of the quality movements and progress, this is more in terms of the how their quality, how quality evolved, how it changed over years. So this basically started somewhere in the 1950s in Japan. So that's why those guys are very good when it comes to their production systems. So the quality philosophy, it includes basically what we call mainly continuous improvement, and it makes use of statistical techniques. Quality improvement, in this case, it basically refers to you to like you're continuously improving. They call it in Japan they have a term called kaizen. So it's for continuous improvement. So there are also other things that came about later in project in quality, things like total quality management. So this one involves the entire organization. So from the CEO to the cleaners, everyone should be involved in improving the quality of the organization. But in this case now, it will be, since this is a project, it will now be from the, let's say from the project manager to the person who is carrying out the last details of the project, or the person on the ground. They should all be involved in these improvement initiatives. And there are things now like lean production. It basically involves, it's all about eliminating wastes that you might have in the process. Now, this process that I'm referring to now is the process where you are now coming up with that deliverable now, that end product that you want to achieve for the project. It's also what we call Six Sigma. This is when now they want to have their product to reach, to be as near to perfection as possible. So Lean Six Sigma, it basically refers to the fact that if the quality of your product is controlled to six standard deviations, it means that there would be less than 3.4 parts per million of defects in the process. So it's near perfection that they want to achieve. So you strive to achieve perfection in your process while carrying out that project. So there are mainly what we call 7 types of lean wastes. That's inventory, waiting, defects, overproduction, motion, unnecessary movement, and also that's transportation also, and overprocessing. For a project, it's mainly, especially defects and overprocessing. Let's say you are producing something and then that your end deliverable, it's having defects. So that will become a problem again. The other waste types of wastes like inventory, overproduction, all those other ones, they might end up increasing the cost of production, and then you might end up affecting the cost constraint of your project. Okay, the other thing again is in terms of your total quality management. Total quality management, like I said, it involves all the employees. So everyone involved in that project, from the top to the lowest person, the lowest ranked person, they will all be involved in improving the quality of the within that project. And the focus is on the customer. You focus on what the customer wants, so you can make the customer happy. And then they do continuous improvement, quality improvement, and make sure everything is done accurately. Have you guys done some? Probably you've come across some of this, isn't it?
Yes, sir.
Have you guys come across these concepts?
Total quality management, yes, and waste of lean.
Yes, yes. They are more into industrial engineering, they're the ones who usually do most of this. But at the end of the day, quality is just quality. It does not matter where you are.
What industry you're from?
Yeah. Okay. So there are a number of quality management principles that are used in industry. So it involves improvement, like what you were talking about, continuous improvement, Lean Six Sigma, Lean Six Sigma itself alone. So and using evidence-based decision making. So here you want to whatever decision you're making, you want to have evidence. Okay, you need to have proof to make your decisions. When you guys become metallurgists, you'll be having a lot of data in the plant. So when you're carrying out a specific project or you want to analyze something, you can actually gather all that data and then you analyze it. You draw up some trends or some charts, and then you can see what is happening. So from that, you make a decision. So you should always strive to make a decision based on the data or on evidence. And then this process approach. This is more of a systematic approach to the entire process. So you need to evaluate the system as a whole, not just as an individual unit. So you need to understand the whole system of the project. So like that, it will enable you to make better contributions to your improvements. And you also need to engage with the people on the ground. That's why you need to have those people skills. You need to go to the people. You need to understand what they are doing, then spend some time with them, ask them how things are going. If there are issues, you should go. They should tell you. Then you can see how you can address it as a team. And again, leadership again comes back. There is no way you can achieve the whole project objectives without making use of leadership skills. Because you need to work as a team. Because you cannot be everywhere. So you need to have a vision in place, and then you need to strategize on how you're going to achieve that vision. And everyone should be aligned. And most importantly, you need to focus on the customer, what the customer wants you to produce. If you make this clear, what the customer wants to produce, when you're making use of your leadership skills, it means now all the employees will be focusing on making the customer happy, and then which will increase your chances of succeeding in that project. Okay. Okay, there are a number of project quality management processes. It's mainly three of them. Okay, project quality management. So in terms of project management, everything that you do first starts off with planning, of course, everything. So remember, we have touched on planning, on the planning aspect already. So immediately after your initiation, you start with your planning. Remember your web breakdown structure, your network diagrams, your costs, all those things, web breakdown structure, everything that you have done there, you're gonna have to incorporate project quality in it. Let's say now you said you are going to make use of a specific material. How do you ensure that it's of the right quality? How do you ensure that the standard will satisfy the customer expectations? You need to put that in place. So the first stage of project quality management is planning. So in here, you need to set the requirements and standards that needs to be met, and also the actions that you need to apply. Okay, and the next thing is quality assurance. Just like for the project lifecycle, after planning, you usually implement or yeah, you execute. It's the same thing again with quality. So after you have planned for quality, you need to implement or you need to action those plans. This is now when it comes to execution, it's more of quality assurance. So basically quality assurance, here you are performing the planned quality activities. And then you ensure that the quality standards are met. So whatever you said you are going to plan here, you need to assure project sponsor or whoever put his money into that project, you need to assure them that you are actually implementing those things so that you can meet those standards. And then while you are implementing or executing those plans, you also need to control it, because without control, how do you make sure now that everything is going accordingly? It's the only way you achieve the quality objectives. So the next thing is quality control. So quality control ensures that the quality assurance or the execution that you have done of the quality plan is performed according to the quality plans. It's just double checking to make sure that everything that was done, it was done according to the plan. How do you think you carry out quality control?
I think the first sort of step that one needs to take when doing the quality measuring is to sort of have certain, because now I believe they're obviously, say for instance we are targeting producing a certain product. There are certain standards that need to be put in place before we sort of measure the certain quality of the product, and those are sort of say for instance, if we are going to stick to the American standards for this product or to the European ones before we even start measuring the quality. I think that is the first step that we probably need to take.
Okay. You need to make sure everything is according to those standards. Okay. Anyone else? How else do you think you can make sure you can do your quality control?
ISO standards.
Yes. What? How else can you make sure?
Using the ISO standards, whatever they're called.
Yes. Okay.
You can also carry out quality test.
Quality test.
Mm.
Yes. Yes. That's right. Yeah. You can always double check and make sure.
Yeah.
And most of the time, you know that you have done your quality planning. So from quality planning, you will have you have a lot of action plans that in place. So it means now you can, for each activity that you plan to do, or for each quality aspect that you plan to achieve, you can actually test it, like he said, and you can actually have something like a checklist where you're testing quality. So that you make sure that everything has been achieved. There are a lot of other tools. We'll look at them soon also, like the issue. Uh, there are a number of charts that you can make also. You can do root cause analysis. You can do some control charts. You can use Pareto charts. You can, quite a number of them. We'll get to them soon. Okay, so now let's just have a more detailed view into this. So, like I said, for project quality management, there are three processes. It's project planning, it's quality planning, quality control, and also quality assurance. Okay, so let's start off with quality planning. So when you're planning for quality, you need to come up to an agreement. You need to come to an agreement on the standards and specifications that must be met. So you can discuss this, let's say with your customer or with your client, and come to an agreement about that, so that at the end those things must be achieved. It depends now on the type of project you are working on. Okay, and there are and also the metrics for meeting those specifications. This is just in terms of the measurements. Let's say now, if you say the product is of high quality, what exactly are you talking about? How do you measure that? It's like the KPIs that one should look at, and the criteria for authorizing project phases. If you can decide that if you achieve, let's say, these three milestones, then you can say that you are done with that phase of the project. And then you also need to agree on what tools and techniques you should use you should make use of during your quality assurance and quality control, and also the activities that you should apply. And most importantly, sometimes you need to benchmark with uh, best practices in the industry or some other similar projects that were executed. It depends on the project you are working on. Some of the projects are unique. You will not find similar projects done somewhere else. So it depends. And also, most importantly, you need to check your cost again. This is in terms of the cost for quality. We will look at it also later. This is there are mainly two types of costs. There's cost of conformance and cost of non-conformance. So you need to plan for that also. And on your project quality control, there are a number of tools that you can use. You can always make use of your configuration control. Yeah, and like I said, you should use inspections, defect reporting, and acceptance tests, like your colleague said. You can do those tests to make sure that the quality has been reached. And there are also other investigation, problem-solving tools that you can use. So you need to repair all the defects and then investigate also the non-conformities. There are a number of tools that you can use, again, in terms of investigating. When you're investigating, you can use maybe, let's say, the cause and effect diagram to analyze this in terms of your root cause analysis. Yeah, and there's also even they spoke of cause and effect techniques. There are quite a number of tools. We'll get to them also, like I say. And in terms of your quality assurance, so basically what has happened is most of your quality control is the inputs are coming from your quality plan and also from quality assurance. Because what you want to do is you want to control and make sure that what was planned has actually been actioned during your quality assurance. And when it comes to quality assurance, you need to make sure that let's say, depending on the type of project you're working on, maybe there is a need to train the project team members. So you identify that skills set which is lacking, then you give them that training. And there will be a number of authorization phases that you come across. Then when you're authorizing, you need to make sure that things are done according to the plan that was in place. And then you need so also things like design reviews. For design reviews, again, we'll look at it later, but just in general, when you are, depending on the project you are working on, if it involves some designs, it means those designs needs to be reviewed. So one of your engineers will be responsible for going through those designs and make sure that where there's supposed to be a valve, there's a valve. Where there's supposed to be a tank, there's a tank, all that. So it depends. All the designs can be done now, depending on which designs you are working on. Can be PFDs, P&IDs, all those designs, one by one. And that's when now, in terms of your registration with the council and all those legal requirements that come with it, they'll get involved in there. There's also, you can make use of what you call the failure mode and effect analysis. It's just a tool, again, that you can use to make sure all the activities that you plan to execute are executed. And you can also do modeling, prototyping, and testing. Here it's like you want to represent what the real events by making use of let's say, by doing it at a small scale. So you can think of doing, let's say, pilot testing. You can run it there also. When you are designing, let's say, a plant, you need to also, at some point, you need to pilot test it and see if it will behave according to your designs. And if it does not, then you make some adjustments. Yeah, the other things that you can use is also like checklists. Checklists are also important, but most of the time they are more reactive. But you would want to use something which is a bit proactive so that you don't waste time. You just want to do it once off. Okay, and then when it comes to continuous improvement, there are a number of learning opportunities, but this normally comes most of the time at the very end of the project. This is at the closeout project, when you're closing the project. or maybe when you're closing a specific phase of the project. Okay, when it comes to project closeout meetings, we have gone through that in the previous lecture. So you're gonna have some, especially when you have a project post-evaluation meeting, or they also call it a postmortem, project postmortem meeting. There you're gonna have to evaluate everything about the project. So in there, you're gonna have to learn to learn a lot of things now in terms of what worked and what did not work, and maybe the way forward so that you can incorporate it in next time you're doing a similar project. And then after that, you give reports. Okay, the other thing is, again, that I might not gone through for long is configuration management. Configuration management is all about managing change. So you need to make sure that any changes that are related to the final product specifications, if there are any changes to the final product that you are delivering, they need to be updated in that document. So the idea is that you want to make sure that whenever, let's say you are doing design reviews, when someone is asking for the design, they should not take the previous or the previous design if this design has been updated. So you need to manage all those changes. Okay, there are a lot of types of, there are two main types of costs for a project. One of them is cost of conformance. This is mainly prevention costs. Okay, this is now in terms of your engineering controls that you are putting in place, maybe just to make sure the quality of the product does not get affected, and maybe the training that you are giving to your team. There's also appraisal and controls. This is in terms of your inspections that you are doing on the product. And cost of non-conformance, this is normally done when the product is already, it has already failed in terms of the quality. So in this case, the product has failed. Let's say now the cost that you have incurred when the quality has failed, this can be experienced within the company or outside the company. So for that, we have internal failure costs and external failure costs. Okay, so if it's internal, it can be things like rejects, reprocessing, or defects that you are, when the product is still within your control. So sometimes you can reprocess it, or you try to work it out again. So that double work that you're doing, it's the internal cost that you're experiencing. And if that product has gone outside, it becomes now the external failure cost. So if that product is gone, you have to send someone to go repair that product there, or to go replace it, all that. Even things of warranty, it's also a big issue also. The cost of non-conformance. Okay, this graph here is just illustrating those costs on the graph, on some trends. As you can see here, you have your quality level, the horizontal axis, and quality cost on the vertical axis. The green one that you see is more of prevention costs. It's prevention costs, so it's more of a cost of conformance, while the orange one is failure costs. So it's both in external and internal failure. So these are non-conformance costs. And the one that you see at the top here, this is your total cost. It's just basically an addition of your failure costs plus your prevention costs. You add them up and then it forms out. So the idea here is you don't want to keep your quality costs too high. You want to keep them just at the minimal, so that you don't experience too much, you don't exceed your cost constraint. Remember the triple constraints? You don't want to exceed that. So you need to give just enough so that you have achieved all the objectives or the expectations of the customer. And then again, when it comes to design reviews, so like you guys are metallurgists, you'll be required to go through designs for that plant. So in that review that you'll be doing, it can be a PFD or in the PNID. In that review, you will be looking out for omissions. If there are any errors, any mistakes maybe, you need to check out for compliance to specifications, like those ISO standards you're talking about. You need to look out for safety and product liability. Is the product reliable? Can it work for long without breaking? If you say your plant is 90% available, is that really the case? You do some calculations to verify that. Manufacturability, can this really be manufactured? Operability, maintainability, can it be maintained? And also standards, we'll also look more into standards again. So this is a typical plant. Here you have a gold plant. So you'll be given designs. It's just that this, I could not find the proper P and ID to put here. It's too big. It will not fit well here. But you understand the concept, right?
Yes, sir.
Okay. So you'll be required to go through the entire design and make sure that everything is where it's supposed to be. If let's say they forgot to have this should have been a density measuring device somewhere here, then you need to make sure about that. But most of those things you will see them in the P and ID. So even for bigger projects, let's say refinery conversion, they must have gone through this process. Sometimes you are not necessarily the one who is doing the designs themselves. Sometimes you have contracted that design aspect to, let's say, other companies. Let's say you can bring in Metal or WE Minerals or Barrowworld or whatever, those big companies that own specific technologies. And you can ask them you can give them like a tender so that they can design that plan for you and incorporate that. Let's say if it's a roaster, they incorporate the roaster into into your refinery. And for you now, once they've done with the design, they send those designs to you. For you, for you now is to, for you that the only thing that you need to do now is to go through the design and make sure that everything is where it's supposed to be. There are also issues of compatibility. You need to make sure like that the equipment that they are using are compatible with your system. Let's say with your SCADA system, that's supervisory control and data acquisition. You need to make sure if you are using Siemens and those guys are bringing in Samsung or something else, HP or other devices, you need to make sure that they are compatible. Otherwise, you're going to have bigger problems again. Okay, and in terms of quality standards, so the quality standards ensure that companies meet the minimum requirements of the customers. So it's mainly in terms of safety, that's the first thing, and also meeting the customer expectations. Some of the plans, they require equipment that fit specific objectives or that are friendly in a specific way. Let's say in terms of safety. Let's say in Essex, for example, I like using Essex because there's a big risk in that plant. Because of your use, there's a lot of fuel that you're using in there, that diluent that you're using. You can't put a pump that can actually ignite or that can burn out. You need to make sure that that pump does not burn no matter what, no matter how long it runs. It must be completely sealed. There shouldn't be a spark coming from it. Otherwise, you end up burning down your Essex because of the equipment that you've used. So you need to comply to those standards. So ISO 9,
Sir,
yes?
do we, it's about to disconnect. Do we come back after it disconnects, or and how
Yeah,
long does it?
I'll send you another link on WhatsApp. Yes.
Yeah.
Okay. Okay, why don't we just come back after, then we can start with this slide perhaps.
Okay, so
After?
Is let's say after how long? Let's say 5 minutes. Is it fine?
Okay,
Yes,
sir.
sir.
Then you can come back at 15 past 10. Then
Cool, cool.
you can
Okay.
continue quality standards.
Yeah.
Okay. Quarter past. Okay, let me log out.